Alright guys, today we're going to be learning about piecewise functions. That might sound a little silly, but once we actually talk about them, it'll make perfect sense to you. So, get a handout of the notes. It should look exactly like what I have up here on the board. It's just a fill in the blank, kind of follow along. So you're going to do just that. You're going to fill in the blank, you're going to follow along. I'll give you some time to work on a few of the questions in there on your own. And hopefully by the time this fairly short lesson is over, then you'll be good to go. Alright, so let's get started. Piecewise functions are functions that are made up of different pieces. That's why it's called a piecewise. So if you look at the picture here, this picture is a piecewise function. It has two different parts. It has this kind of darker red part on the left and this kind of pinkish red down here on the right. Okay, two parts. Step number one is that we need to write equations for those two parts. Okay, I have two parts, they have different equations. I want to know what those equations are. So, looking at the first part, and we have to kind of visualize if this was continuing this pattern, what kind of function would this be if it was a whole picture, right? I know it's only part of a picture, but if we pretend like we had the whole thing, what function would that be? So, y equals what? Well, I can see that it's sort of parabola shaped, yes. It looks like the vertex is here at 0, 0. So I'm guessing it's something like x squared. I need to check the steepness of my graph here. So I'm going to look at some of the points on it. Negative 1, 1. Negative 2, 4. That looks to be a standard x squared parabola. Hopefully you already know that. Kind of dig back into your Algebra 1 drawer in your brain and recall that information about parabolas. Standard position has that vertex at 0, 0 and has these points 1, 1 and 2, 4. So y equals x squared, easy. That's what the equation would be if I had the whole picture. Now look at the second part. Okay, if I had this particular function here and it continued in both directions and continued with this pattern here, what would it look like? So this equation, y equals, this is linear, so that's nice. Its slope, up 1 over 1, looks like to be just a positive 1. And its y-intercept, again, if this continued on, would be negative 1, right here. Okay, now, we'll get back to that circle that's there in just a minute. So the reason why it's not actually a point, we'll talk about that in a second. Okay? So, first step is, can I write equations? So we have two equations. I'm going to try to keep everything color-coded so that you can hopefully follow along putting all the parts together. Alright? Our second step says, okay, look back at each of those pieces and tell me what x values, what is the domain for each of those pieces. So for the first piece, the blue piece, I put the equation in blue, that's this half parabola here, okay. What values does that cover? We're going to assume that this line keeps going off of the graph, same thing on this side, okay. So if that's the case, then what x values does this go? What would it cover? So it would cover from negative infinity all the way up here to 0, and notice that's a filled in dot, so including 0. Interval notation, that would be negative infinity to 0, square bracket. If I write that as an inequality, that would be my x values, where x is less than or equal to 0. Then we do the same thing for the purple, or the second part. Second part looks like it goes to positive infinity, and again we'll assume it does. So from positive infinity all the way back here to 0, but notice that open circle. So if you're wondering why it's there, there we go. It's actually an open circle at 0. So this one, the interval goes from 0, not included, so I use a parenthesis, all the way up to infinity. As an inequality, that would be all my x values that are greater than 0, but not equal. So then to write an actual piecewise function, the way you're going to see it written is just a combination of those parts. So it's a combination of the equation and the domain for that equation. So I'm going to take those two parts that I have there and put them together into my actual equation of my piecewise function. So piecewise functions look a little fancy. They look fancy with this little fancy bracket there. The bracket we use for set notation. This says f of x equals two parts. So I have a line for each of the parts. So I'm going to put what f of x equals. Okay. Now Now remember, f of x is the same as saying y. So f of x equals is the same as saying y equals. So when I put my equation on this line, I don't need the y equals. I need just what does it equal. So x squared for the first part and x minus 1 for the second part. Then the other part of this says for. For what values of x? That's kind of what I'm asking here. Y equals x squared when? So if you want to think of that as it's saying when. When does it equal x squared? Well, it equals x squared when x is less than or equal to 0. And it equals x minus 1 when x is greater than 0. So for all values of x where x is less than or equal to 0, y equals x squared. Okay, so that's kind of the way you would read those two kind of parts put together. Hopefully you're still with me. If not, you can stop, you can back up, you can hear me explain it again. Okay. So this equation tells us that there are two parts to our function. First part up here, second part here, right? Two parts. And I want to know where those two parts are valid. In other words, the domain for each of those parts. So when I plug in a value, which part am I plugging it into? I need to know those x values in order to know that. All right? So we're going to use that piecewise function and the graph of the piecewise function above it to evaluate some points. In order to do that, I'm just going to kind of clean up what I've done here by erasing some stuff that's on our graph. Okay, I'm going to erase that. I'm going to erase some other notes here just because I know I'm going to need to write over them. I'm going to clean it up a little bit. All right. So, evaluate using the graph. So I'm going to find f of negative 2. Remember, that means I'm plugging in negative 2 and I want to know what is y. So if I go to my graph and I plug in negative 2, that's right here on my graph, and my y value is 4. So when I plug in negative 2, I get 4. We'll keep doing that for the rest of these. When I plug in negative 1, I get 1. Point right here on my graph. When we plug in 0, we get 0. Notice that's a tricky one because I have two zeros here, but remember that's an open circle, so it's not equal to 0. And when I plug in 1, I get 0 again. When I plug in 2, I get 1. So those would be the points that I can find using my graph. However, you can also find those points using the equation. So using this equation here. So I'm not even going to scroll back up to the graph. We're going to just use the equation. When I plug in negative 2, so when x is negative 2, I need to plug that into the equation. The tricky part is which part of the equation. So that's where the second half, the when, comes into play. When x is negative 2, that falls into this category. So an f of negative 2, when x equals negative 2, that goes in the blue section. So I plug it in here to this function. So I plug in negative 2 and I square it. Then for negative 1, that's also in that blue section. So I plug in negative 1 and square it. If I plug in 0, that's going to also go in that blue section. 0 squared, 0. Then I'm going to plug in the next two. F of 1, I got to see where that goes, but that doesn't go in the blue section anymore. Now this goes in the purple section because 1 is greater than 0. So now I'm plugging in here to the purple. 1 minus 1, 0. If I plug in 2, again that goes in the purple, so 2 minus 1 is 1. Notice I can kind of compare my answers here. And I can see that I did a good job because I have the same thing on both of them, as I should. Okay, so if I compare those, I can see how I did. So that is finding the equations, finding the intervals, and then writing that equation. Okay. Then we also have using the graph and the equation to find particular values of the function. Page 1. Let's move on to page 2. So, I want you to try this one on your own. So what I want you to do is take a minute to pause the video, do the work. When everybody's ready, come back to the video and hit play, and I'll pick up from right there and I'll give you the answers. I'll walk you through this one because I know it's going to take you a little bit and you may need some explanation. So I'll walk you through the answer here, but you take a minute now to do that work and then come back. All right, go. All right, now that you're back, we're going to go ahead and talk about this function. So we want to write the piecewise function. In order to do that, remember, we have two steps. First step is the equations. So I'm going to look at my two pieces. I'm going to write my equations. So again, pretending like this line goes on infinitely. This is linear. It has a slope of 1 again. And my intercept is positive 4. So this first one is x plus 4. If I want to go ahead and do the second part here, which is the interval, this goes from negative infinity all the way up to, but not including, 1. So if I write that as an interval notation, negative infinity to 1, or as inequality, which is how we write them for piecewise, x is less than 1. Okay? Now I'm going to do the other part. My other piece of my function, this bottom piece. Let's see, it is also linear. The slope is 2 over 1, and it's negative, so negative 2x. And my intercept, I can't see it, but if I keep my slope here going, it would go up here to negative 1. So negative 2x minus 1. And my interval here, let me erase some of this stuff, it's cluttering up my picture. My interval here goes from 1, including 1, up to positive infinity. So including 1 up to infinity, or I could write that as x is greater than or equal to 1. Alright. So I've got my two equations, I've got my intervals. Again, I'm going to kind of erase some stuff here because it's cluttering up my picture, and I don't like that. I want to be able to read my graph a little bit better. Okay? And now I'm going to evaluate the piecewise function for these values. You can do this whichever order you want to do. If you want to plug it into the graph and use the graph, that's fine. If you want to plug it into your equation, use your equation, you can do that too. I think I'm going to use the graph because I think it's easy to read. So, g of negative 6. When x is negative 6, right here, this point on my graph would be y is negative 2. If I plug in 1, again the tricky one, doesn't equal on this one because it's an open circle, so I have to go down here and get negative 3. If I plug in 2, that's on this graph, negative 5. Okay? So that's how we would find those. Or you could plug them into these. You should get the same answer either way. Alright, so we've talked about so far writing piecewise functions and then using them to evaluate certain values on the function. Okay, so that's the first video. We have one more video. It's just the next page in your notes. And so we are going to do that in the next video. This was part 1, so you can turn this one off and start part 2, and we will finish up the notes in part 2. I just don't want the videos to be super long. Alright, so I will see you in part 2.